Okay, calculus students, please don't be intimidated by this section. Really kind of on a scale of 1 to 3, I want you to know that before for this section, we've kind of shot it at 2 in terms of level of difficulty, but I've really brought it down to a 1 for this time being. This is going to look intimidating as you find these derivatives, but in fact, um, again, you're going to have your notes on the test, and you'll be able to reference these. We're going to make them pretty straightforward for you. So arc sine, arc cosine, sine, cosine, so on and so forth. What is this? Well, last year we got shoved into our distance learning time, and I just want you to understand what we have a little bit. So just give you a brief overview. Y is equal to sine of x. Okay, you know what that graph looks like. Looks like that, and it continues on, so on and so forth. And if you consider the graph, it starts, at 0, and then we have pi over 2. We have pi. We have 3 pi over 2. And then we have 2 pi. And now I want to think about y is equal to this one. These mean the same thing, arc sine and sine inverse. It does not mean 1 over sine of x, okay? That's the same thing as cosecant of x. So just know what you're talking about in this situation. Sine inverse means that if you're given a value, what is the angle? So let me give you an example here. It's true that if you have a 30-degree angle, and this side is 10, I'm sorry, whoops. This side is 1. The short side is 1/2, and the other side is the root of 3 over 2. That created that terminal point there of root of 3 over 2 and 1/2, as you have kind of learned through this time period. So what we know in that situation is this, is that the sine of 30 degrees is equal to 1/2. So that means that the sine inverse, or arc sine, of 1/2 produces 30 degrees. Now, in calculus, we like to work in radians. So the sine of pi over 6 is equal to 1/2. The arc sine of 1/2 is equal to pi over 6, which is about, say, 0.51 or something like that, okay? So the sine inverse function, it produces those angle values. And its graph actually looks a little bit different than what you see up here. The graph actually looks something like that. And it starts and stops there. It doesn't continue on in this way, because then it wouldn't be a function anymore. So it just has to be this small segment there. And that's the sine inverse, or arc sine function. So that's what it is. It doesn't mean you entirely understand it. It doesn't mean you know all of its domain and range and everything, but it is a function. You do use it. On your calculator, we do sine inverse all the time. But what is its derivative? And again, I just want to be clear that the derivative of arc sine is the same as derivative of sine inverse. Those mean the same thing. In this situation, it is 1 over the square root of 1 minus x squared. I'm going to go on to arc tangent. The derivative of arc tangent, or 1 over, or tangent inverse, is 1 over 1 plus x squared. So you can see that they both have a 1 over. The derivative of arc secant is 1 over x roots of x squared minus 1. So the derivative of sine, arc tangent, and arc secant, they are all positive. The nice thing is, once you know those, you know the others. Arc cosine is the same as arc sine, it's just negative. Arc cotangent is the same as arc tangent, it's just negative. And arc cosecant is the same as arc secant, it's just negative. So there you have some of those derivatives. Find the derivative of the following functions. Arc cosine of e to the x. F of x is, I'm going to rewrite this as cosine inverse of e to the x. Looks like an impossible derivative. We're going to make it really easy. We make the chain rule, the greatest rule of all for derivatives. We have arc cosine or cosine inverse of u, and we have e to the x. The derivative of e to the x is e to the x. And the derivative of arc cosine of u is -1 over the square root of 1 minus u squared. So what I'm going to do is I'm going to multiply these together. And when I do multiply these together, I get a negative e to the x in the numerator. And in the denominator, I have the square root of 1 minus, I have to plug that e to the x in for u, and I square it, so I get e to the 2x. And that's it. Look at the next one, tangent inverse, or arctangent. Arctangent of u and 4 minus 2x. The derivative of 4 minus 2x is -2. The derivative of arctangent of u is 1 over 1 plus u squared. When I multiply these together, I get -2 on top, and on the bottom 1 plus 4 minus 2x quantity squared. You don't need to multiply that out. That's it. Sine inverse of the root of x. Arc sine of u, root of x. The derivative of the root of x is 1 over 2 roots of x. The derivative of arc sine of u is 1 over square root of 1 minus u squared. So as you multiply these, you get 1 in the numerator, the denominator 2 roots of x. Then you have times the root of, and it's 1 minus u squared. If you square the root of x, you get x. So you could multiply these radicals together, 1 over 2 roots of x minus x squared. Now, don't get too worked up, but in this situation, you can see we have the product rule. So we're going to take the derivative of x, which is 1, times the natural log of arc cotangent, or cotangent inverse of x. We have plus x times, now we just need the derivative of natural log of arc cotangent of x. That's going to require the use of the chain rule. I have the natural log of u. I have cotangent inverse of x. The derivative of cotangent inverse is -1 over 1 plus x squared. The derivative of natural log of u is 1 over u. When you multiply these together, you do get -1 over cotangent inverse of x times 1 plus x squared. So we're going to put that guy right there. Notice that the derivative comes out to be f prime of x is equal to the natural log of cotangent inverse of x minus x over cotangent inverse of x times 1 plus x squared. It really is a remarkable derivative when you look at it. It looks impossible to be able to deal with. In fact, it's really not as bad as we thought. Time we deal with a cosecant or secant option. In this situation, I will set it up again with the chain rule, the cosecant inverse of u. And the inside is e to the 3x plus 1. The derivative of cosecant inverse of u is -1 over u roots of u squared minus 1. The derivative of e to the 3x plus 1. We've been over this before. You do use the chain rule. It turns out you just have to take the derivative of the top, which is 3, times e to the 3x plus 1. So it works out as simple as that. So we just did the chain rule. If you don't believe me, set up the chain rule boxes and go ahead and do it that way. We multiply these together. A little trick here. You can see that the -3e to the 3x plus 1 is in the numerator. And the denominator, we need to dump this in for both of the u locations. And so we get e to the 3x plus 1 root of e to the, when we square it, we get 6x plus 2 minus 1. Notice what cancels. And we get -3 over the root of e to the 6x plus 2 minus 1. Very good. We're just going to skip 6. It's really not that bad. But it's really not necessary. I think you've seen enough. These are all the different derivatives. Just to make sure that we're on the same page. Your power rule, x to the nth. The derivative is n times x to the n minus 1. Your product rule, the derivative is f prime g plus g prime f. F divided by g, the derivative is f prime g minus g prime f, all divided by g squared. The chain rule, the derivative of a composition function, we take the derivative of the outside with the inside left alone times the derivative of the inside. Those are our major rules. Along with those, we tack on a few more. The derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine of x. The derivative of tangent of x is secant squared of x. The derivative of secant of x is secant of x times the tangent of x. The derivative of cotangent of x is negative cosecant squared of x. The derivative of cosecant of x is negative cosecant of x times cotangent of x. The derivative of e to the x is e to the x. The derivative of something that has a base different than e is b to the x times the natural log of b. The derivative of natural log of x is 1 over x. The derivative of log base b when the base is different is 1 over x times the natural log of b. The derivative of arc sine of x is 1 over the root of 1 minus x squared. The derivative of arc cosine of x is negative 1 over the root of 1 minus x squared. The derivative of arc tangent of x is 1 over 1 plus x squared. The derivative of arc cotangent of x is negative 1 over 1 plus x squared. The derivative of arc secant of x is 1 over x roots of x squared minus 1. And the derivative of arc cosecant of x, sorry about the horrible writing there, is negative 1 over x roots of x squared minus 1. There's the list. Those are the derivatives. The good news is you don't have to memorize them. You get the notes. The bad news is you still need to have reference for them and understand how to use them. And that's what we'll be focused on in class. Have a good day, folks. We'll see you later. Great luck. I hope to work through some problems with you.